All right, great. So yes, RabbitMQ and the story of rules Erlang. So first, I want to say, if you obey all the rules, you miss all the fun. And the first rule that I will probably break is I will probably say Bazel and not Bazel, because I learned about Bazel right in the heart of the pandemic, and there was no one to talk about it with. First, what is RabbitMQ? RabbitMQ is a multi-protocol message broker. So you post messages to exchanges, they get routed to queues, consumers consume message from the queues. And we also added more recently streams, so that's non-destructive consume. RabbitMQ is written in Erlang, and that's a general purpose, concurrent, functional, high-level programming language with a garbage collected runtime. And it uses a virtual machine and it has platform-independent bytecode. RabbitMQ was started in February of 2007, so it's been around a long time, and it's open source. What is rules Erlang? Well, everybody at BazelCon can probably guess, but there are Bazel rules for building Erlang applications, and they're also open source. So I promised you all a story. Once upon a time, RabbitMQ had a build problem. In the old times, and this is early 2020, which is around when I joined the team. So the RabbitMQ broker was built and shipped from around 30 different GitHub repositories. And we had an umbrella repo. You could use that umbrella repo to clone all the other repos and build stuff and run tests and so on. And if you ran make tests in the umbrella repo, it took several hours locally. I'm pretty sure I never got the whole suite to pass on my machine. We had our CI/CD in a dedicated Concourse CI cluster. And when we rendered out the pipeline YAML from our templates for a single release pipeline, it was almost 30,000 lines of YAML. So they were really big pipelines. They were so big that if you tried to render the whole pipeline in a single Concourse view, it would break Concourse, at least back then. So we had to split it up into multiple views, and that's why I have no screenshot of it, because it's not that impressive when split up. When you pushed a commit, it took 2 to 3 hours for that commit to run through the pipeline and be green. And that wasn't the entire pipeline, because the release pipeline had packaging and upgrade tests and building of release artifacts and all those things. So that was like, if you wanted to do one of those, you'd get the results the next day. But like the primary test, primary stuff took 2 to 3 hours. And there were test flakes, which means that often it would go red anyway. You have to rerun some stuff or something like that. Also, the way Concourse works, it has a notion of resources and jobs. So a resource could be like a branch of a Git repository, or it could be a Docker image. And a job is arbitrary stuff that you run once you fetch the resources, and a job might put to another resource to update the rest of the world. So because we had all of these repos, and because in Concourse a Git repository resource is a branch, you just had to do your release branches. So you could only run the tests after you had merged something to a release branch or the main branch as well, but you couldn't test a PR in any sort of reasonable way. There's some hacks around that. If you've got a small project, there is a Concourse resource that you can sort of meta-program Concourse with, but for something like this, it wouldn't work. Oh, and so the main thing was you couldn't wait for CI to be green before pushing a new commit, and that caused all the usual problems that sort of thing does. Is there's multiple commits, you have to revert something that's many commits behind, and it was not great. And while this was certainly not perfect, it was still okay. Like, we continued to ship new versions of Rabbit. There weren't too many regressions. Having slow tests is way better than having slow tests at all. And people that had been on the team for a while kind of knew the code base. They knew if they changed something here, these are the suites that I could run, keep things efficient, and feel pretty confident about what they pushed. Although that's not true if you're a new member of the team. And so we thought this could probably be so much better. At least we hoped it could. It actually got a little worse before it got better. So we're getting into mid-2020 here. So we had the code in those 30 repositories. And why did we have that? So Erlang programs Erlang code can be organized into applications. Most of those repos were an Erlang application, and the RabbitMQ message broker has sort of a core Erlang application. And there are lots of what we call the tier 1 plugins. So they ship with Rabbit, and they add core functionality like support for new protocols or authentication mechanisms or all sorts of stuff. So we always shipped it all at once, even though it would have been possible, say, to like upgrade the core broker, but not the management UI. But we never tested that. We already had the 30,000 lines of YAML. We didn't want more. So we decided to roll these into a single monorepo. And that was good. It became possible to like do a git bisect. You could just check out the branch and have everything. You didn't need the umbrella repo in the same way. But because Concourse was this graph of the repos and jobs, it had this inherent test caching to it. The plugins, the tier 1 plugins were downstream of the core broker. And so there was some inherent test caching there. And when we went to the monorepo, it broke it all because everything just depended on the monorepo, and we got more and more flakes. So finding Bazel. 2 to 3 hours for one of your commits to run through the pipeline is a lot of time for research. So during that time, lots of ideas were generated. So we thought about different things. Like with Concourse, we could have filtered the paths of the monorepo to make it look like all the original different repos and restore that graph. But being able to go back to the same number of flakes, still 2 to 3 hours, wasn't that good. So that didn't seem great. We thought about building our own test result caching mechanism into the pipeline. So maybe we write test results and get JAWS into a database, and fetch those, and short circuit parts of the pipeline. Another thing we could do is just have fewer integration tests and try and make the suite faster overall. But all those things seemed like an awful lot of work. And it usually felt like, especially test result caching, would be reinventing the wheel. Like we could build Rabbit and we could ship Rabbit. So we already had somewhere in the build a notion of what plugins depended on what, because some plugins are interdependent, and the order of everything. And we just couldn't use it in CI. We were replicating all that. So we found Bazel, and we were tempted. It sounded great, fast and correct, very nice. The test result caching seemed like it would work very well for us. Remote build execution seemed great because maybe we could dump that Concourse cluster that would fall over sometimes, and we'd spend like half a day restoring it, and it was expensive. It ran on GCP. And we do ship Rabbit for Windows and Linux. We don't really, well, there might be a homebrew formula for Mac, but anyway, having that cross-platform support in the build did seem like it was important. But on the other hand, nobody on the team knew Bazel at all. We knew the current build very well. It was makefiles, and it used another, I guess you'd call it a make plugin or a makefile, Erlang MK, that knew how to build Erlang stuff. So we knew that pretty well. We knew the author of Erlang MK, and they actually joined the Rabbit team since then. This was a big one, is Bazel had no rules for Erlang or Elixir. And Elixir is another language that targets the same VM as Erlang. So that wasn't so good. And we read some blog posts, and they were kind of scary, that said, like, unless you have a crazy build that needs something really powerful, this is not a good idea. Everything has to be hermetic. And we read some of the Bazel docs. We said, yeah, it probably should be hermetic, and we should probably build Erlang with Bazel. And we read the docs about platforms and tool chains. And we were like, let's not. And back away slowly. And that's kind of what we did for a little bit. But then we still had those long build times, and we still had time to research things. So we started to say, what if we broke some of the rules? The metric that we really care about is that 2 to 3 hours, and we want to get that down as low as possible. So what if we cheated? What if we just use Erlang from the host? What if we just worried about CI and said local development doesn't matter, but just keep using make and Erlang MK? And what if we use something like BuildBuddy or something like that to make RBE really easy, and then we could get rid of the Concourse cluster? And with that, we had an initial commit to Bazel Erlang on November 20th, 2020. So the question is, could Bazel help us slay the build dragon? And the answer, I think, is a resounding yes. So we were able to get to green commits in about 20 minutes. So this was the pull request that brought it live into RabbitMQ server. It was number 2398. I don't remember what it was called. It was big. It was 221 commits. We merged on March 29th, 2021. It used Bazel Erlang master because we didn't want to tag it 1.0 yet. We weren't that confident. And when we did that, it deleted about 5,000 lines of GitHub Actions YAML and replaced it with just 54 because it basically became like set up Basilisk and Bazel test // ... And it used both remote cache and RB from BuildBuddy right away. So we didn't add RB later. It was kind of there from the beginning for us. And everyone lived happily ever after. Well, that's kind of true, but not quite. We didn't stop. So what we had at this point was we had green builds many times a day. And this was absolutely amazing because honestly, we used to rarely have a fully green build on a day. So this was great. Now we had just a Bazel build setting for where the host Erlang was and what version it was. So this is how we invalidated the cache when we switched the Erlang version because we would do that pretty often. Erlang applications, you can usually get away with compiling a single application like one call to ErlC, but sometimes you have to compile some files first, and we just wrote that into the build files. We had pretty basic external dependency support, so we always pinned all of the dependencies anyway, so we had all of the transitive dependencies already listed in our build for the most part. So we just listed them all. And it was pretty basic, but it worked. And that was the thing. Like we felt like we had something that worked well for us, worked well for RabbitMQ, but probably didn't work all that well for anybody else. So what was missing? What would we like to have? Well, just enough confidence to call it a 1.0 would have been nice. A rule set that was useful to other teams, a better way to manage the Erlang versions, convenient external dependencies, at least better than what we had, and make the local development experience better because we didn't really want to have two build systems forever. And there was more. I've kind of forgotten all the things. So we kept working on it. And probably the best way to go through that is just like a brief history of the rules Erlang releases since then. So we got to June of 2021, and at that point, like it was stable enough that let's just tag it. In July, same year, we tagged Bazel Erlang 1.1, where we added support for the Bazel test sharding. That was nice for some of our bigger test suites, especially ones that would flake, because if you shard, it won't rerun the passing shards. So that was nice. Then we got to January of 2022. We learned, oh, this is how rule sets are named in Bazel, so let's rename it. We called it 2.0. And we started getting the Windows builds to work better. We got to version 2.5 in April of 2022. We finally handled the phase compilation automatically, and that was like the first time we built something in Erlang and had all the other Erlang rules depend on it. So that was a bit of like, what is a tool in Bazel? And we started to support Bazel mod. Then we get to June of 2022, rules Erlang 3.0. And here, we started to be able to build Erlang inside of the Bazel build. So this was nice. So what we used to do is we would bake Erlang into the Docker image that we would use with BuildBuddy RBE. So we had a different Docker image for each of the Erlang releases that we wanted. And it was a separate thing to manage and all of that. So like it worked like everything else, but it wasn't the best. So now we could build Erlang inside of Bazel. And if we wanted to change the Erlang version, that was just a new PR. How would it work? And that was another great thing about all this is we could finally run tests on PRs. So that original PR was like around number 3,000, where I think like 9,700. And that was 2 years ago. So there's been another 6,000 pull requests. September of 2022, we had rules Erlang 3.6, and here we kind of looked at rules Docker, and we added an @Erlang config repository that detected your host Erlang. and figured out what version it was. So that was nice. You could finally get rid of those build settings. Each person didn't have to have a line or a couple of lines in their Bazel RC file to tell Bazel where things were. When we get to rules Erlang 3.9, we added an experimental Gazelle language extension, so it could parse the Erlang, it could manage some of the dependencies or the internal dependencies automatically, do some nice things there. And then it was actually just last week. So 3.13 added some code coverage support tests. So it's been about 2 years, a little bit more, and looking back on this, how did it go? There are lots of good things. So it was about, and we go from that November commit to the end of, I think it was March. It was like 4 months. And we had basically one person's worth of effort, full time on this. And we got from like, say, an average of 2.5 hours to an average of 17 minutes. Now you can probably all go fact check me on, is it really 17 minutes? Because it is an open source repository, but I think it's still around there. Now, this definitely would not have been possible without something like BuildBuddy. So we used to throw a lot of compute resources at these pipelines, like it was an expensive concourse cluster to run, but it just didn't apply that efficiently. And with RB, with BuildBuddy, like all that compute is accessible. It schedules so cleanly. Without that, we couldn't get down to these build times. That just kind of changed the way that a team can work, because the build is mostly green now. Using RB with local changes, you can run like 50 of a test in parallel and see if it flakes and diagnose flakes. So we're going to have to cut down some of the flakes. And it's nice just not to run all those tests that we already know that they're going to pass. There are things, though, that are not so good. So we still have both build systems. We still have the Erlang MK build, and it's not ideal to have these two. We have some nightly GitHub actions that run a build with both systems. They compare sort of some of the core release artifacts, make sure everything is basically the same. It catches some drift, like it definitely happens where someone will go and update a dependency in the module.bazel file and forget to do it in the make files, or the reverse, things like that. And it's really disruptive to change the way that developers work, like day to day. And we only added code coverage last week, and Erlang MK had code coverage at the beginning, so 2 years ago. So it's taken us like a really long time to close some of those build system like feature gaps, I guess you would call them. So it's not great to have both builds, but I think it serves it kind of makes sense. This was not about having a cool build. This was always about just letting everybody develop faster, push code faster, and enjoy working on Rabbit. So if we had said like, okay, it's Bazel time, it's Bazel time. It's not Erlang MK time anymore. That would have been really, really rough, especially because it's like, well, you just can't do code coverage. So we've got both, and that's not the best thing, but we're probably going to work on continuing to close the gap. We also don't have full parity in the Windows build, so there's some things there. Also, the overall release pipeline, so they still have plenty of stuff in make files. Some of those things don't translate super well to Bazel, so we have like Debian source archives. So that's ships the source of Rabbit, and it builds on the installation machine. So there are rules for building Debian package in Bazel, but not source packages, and it kind of makes sense because it just doesn't really fit the Bazel model that well. And certain things are just like a bit clunky. So we have a module extension for loading other Erlang dependencies from hex.pm, which is the Erlang package manager. And with Bazel mod, the actual repo name goes through the repo mapping. So it's this unpredictable value. And if you specify the wrong one, you just get the normal version. So there's been lots of times where somebody wanted to pull something, patch it locally, try it out, and you're like, I don't see my changes working at all. Like, what's going on? So, it can be rough. And it's more work when you have to author your own full set. So that's certainly true. And one other thing is that we also use the Elixir language for the RabbitMQ CLI. So we have like the basics of a rules Elixir that are embedded inside RabbitMQ server, but they're not sufficiently generic enough for us to extract them. So we'll work on that. I don't know when we'll get to it. The normal tool for building Elixir sources is called Mix, and it really wants to do everything all at once by itself, accumulating on the file system and mutating stuff. So it's actually really a little hacky what we have for a solution for that. But yeah, overall, Bazel has just been like a huge win for RabbitMQ. So what's next? Well, the code coverage is one of the features, and I didn't think we'd get to it by now, but we did. So general usability things. Let's see. I mean, one of the things is maybe trying to speed up compilation. That's not a bottleneck in RabbitMQ, but maybe other people that would use rules Erlang would use it. And with the Gazelle extension, you can either generate basically like a ton of rules, like one rule per source file. So then there's a lot of compilation actions. Or you can generate fewer, which is what we use. And so we do have like persistent workers for that. It's not merged, but that could serve some purpose as well. And I've been told the docs could use some improvement. So we'll work on that as well. So, I think we thought that we were breaking a lot of the Bazel rules when we started with rules Erlang way back, but we are actually doing okay. The build was always correct as far as I can tell. We had maybe a few issues, but very, very few. The team has always felt like comfortable with cache hits, and we do get a good amount of cache hits in our build. So, it's not perfect, but it doesn't have to be. Like, it can be imperfect and still give some really big wins for your project. So, I guess I'm a little bit fast, but time for Q&A. Sure.
Yeah, hi, and thanks for your talk. I'd be interested in the coverage. So I have no idea about Erlang, but did you manage to support the native Bazel coverage command?
Yeah, so you can just run Bazel coverage now. Erlang's interesting in how it does coverage. Like, I looked at Bazel's coverage documentation. It's like, okay, you can check if these compilations should be instrumented, or when your dependencies should be instrumented and do different things. And that's kind of like a very C, or I guess C++ style of things. And it turns out with Erlang, you don't do that. If you want to do coverage, you start up the Erlang VM and you ask the cover application, because the Erlang's runtime libraries are themselves organized in the application. It's called the Open Telecom Platform, because Erlang came from Ericsson, and they did use it for telecom originally. And so you start up the VM, you use the cover application to say instrument either these sources or this compiled bytecode, and then you execute it, and it'll write the cover data. And it writes it into its own format, but you can still use that same library to read it and analyze it and query it. So what we do is we just build another little tool in Erlang that, if coverage is enabled, beginning of the test, we sort of hijack into that Erlang VM and we instrument the files. We run the tests, it writes it out to disk, and then again, if coverage is enabled, we use our extra utility to convert it to LCOB. And then all of Bazel's regular machinery will merge those files, and then you can send it through GenHTML and get a report. So that's actually pretty nice. I had sort of wondered before, like, Bazel seems to generate everything totally independently. So how does it merge? And it is a bit of a special case. So yeah, kind of a shout out to the Bazel Slack channel, because I was going to use some extra I realized undocumented stuff to do our own conversion, our own merging. And it was kind of like, maybe it's not that hard to just convert to LCOB, but that's what we did. It's like it's like a one screen. It's like 100 lines, 150 lines to do that conversion. So it's no big deal.
Okay, so the last point is interesting. So you do convert to LCOF?
Yep.
Yeah, okay. Thank you.
Thanks also for the talk. So you said it takes now 17 minutes or something. Where are most of the time savings? Is it cache tests, cache build?
Yeah, that's a great question. I've not really gone through and analyzed it. So the way that this project is structured, there are a good set of tests that get invalidated almost all the time. So if you do change one of those plugins and only one of those plugins, that will run a pretty small subset and you'll get quite a lot of cache hits. But if you change, there's lots of tests that basically build the whole broker, they start it up, and they usually like white box it. So they load some other code and they RPC into that node and they do some stuff and check some stuff. Those are all at least medium tests. We couldn't reliably get to run in a small size, so under a minute. So a lot of those get invalidated. But if I think about like the averages that I've seen, if we get, like a good number of cache hits, like not 100%, but very high, it'll run in a couple of minutes. And actually, the GitHub Actions portion of it, just getting a GitHub Actions worker ready to kick that off is the slow part. And then if you got more like a medium level, it's around that 15, 20 minutes time. And if you got a PR that like changes out the Erlang version, which essentially invalidates everything, that's maybe like 45 minutes. So how does that work out to the ratio of like how important caching is versus RBE? RBE is very important, clearly. So we are really happy to have found BuildBuddy, and they've been very supportive of our project, and that's worked out really well. So I'd like to know that question. I guess you could just turn off RBE and try and run with the cache to answer that a bit more directly. But the cache hits vary a lot. So we see a lot of we build other stuff with Bazel as well at this point, like some Docker image and things like that, and those can be really quick in certain cases because you've got building the base OS. Well, you've got the base OS, but like building Erlang, and that's a cache hit. And then you've just got taking the Rabbit binaries and injecting them. So it's really quick. So if you look at our BuildBuddy builds, it might say the average is like really small because it includes other stuff that are separate Bazel indications. One more? Okay.
Is there any relationship or comparison to rebar?
In what way?
I don't know if it used rebar under the hood or if just like a speed comparison.
Well, as far as I don't know if there was an attempt before my time at Rabbit to have Rabbit built with rebar. Possibly, but I don't know why it didn't work. I think it would have ultimately been very, very slow for us because rebar is kind of meant for small stuff. I think a lot of Erlang stuff I think are relatively small projects. So I can say that the Gazelle extension will read rebar config to a limited degree, and we'll set up the Bazel build files accordingly. So that's one of our actually workarounds for Windows is we can do Gazelle update repos, and we've got some custom arguments for that to pick something up from say like XPM. It will pull it down. It will recursively run Gazelle extension on that, build up the build file, and then drop that into your main repo. So that means that we didn't have to replicate all of the live auto import logic that we had across all the platforms. So yeah, out of time. Thank you, everyone.